Hey class, I wanted to make a quick video over lists and how they're extremely helpful in Python and how they can help us keep track of multiple things. For our example, let's think of a simple grocery list. If we were to use what we've learned prior to learning about lists, we would have to store each item into a separate variable, much like we did with our budget. Something kind of like this, where we have an individual item per variable. While this is acceptable, sometimes we may want to group things together. In Python, we do this with a list. Much like a list that we would think about to make in everyday life, it's used for grouping like things. So if we were to create a grocery list instead by doing something like this, which is to use the square brackets, we can enter individual items into this list in this way. And what this will allow us to do is keep track of multiple items in one variable. So if I were to print my grocery list and run it, we would see that it actually prints out that list of items. Now, this is really helpful because we can then access these individual items based off their index. The way that we pull data out of a list is by using the index operator. Much like we use the square brackets to define and insert values, we also use them to pull data out. So it will look something similar to this. I've prepared some comments that are kind of made up before, so I don't have to type them all out. But as you can see, if we were to evaluate just looking at it, Python indexes lists by 0 first, not by 1. So if we were to take a look at these comments, we could use the same variable from above and we can access the values by using their indexes. So if I were to create a little truth table here and access the values, I'm going to go ahead and print these different things out so we can see that the value we expect to be at the index is true. So if I go ahead and print this out, you'll notice that each of these indexes return a true value because index 0 really is apples, index 1 really is pears, and so on and so forth. I'm going to go ahead and remove these so that we don't have to worry too much about that printing out a big list of true every time. But it's really nice because we can check with a double equal symbol to see if the value is in the exact index, or if we just want to see if a value is inside of the list, we can use the keyword in. It does not have to be in a print statement. We could do this in an if statement. We could do this in a couple different ways because it evaluates to true or false. But I'm going to go ahead and run this with do we have apples in my groceries? And if we go ahead and run this, you'll see that it prints out true because we do. If I were to try to do something like chocolate, because it's not currently in our list, we would get the value of false. So we can use in to determine if something is in our list, which is really nice. Sometimes, though, we want to be able to add additional items. We can extend our list. I'm going to go ahead and remove this. We can extend our list by using the extend function, which is part of the list class, which we'll get into classes a little bit later. But let's say I've got my grocery list and I want to extend it by adding in another list of values. So we want to add an additional number of values. So we can do carrots and we could do bread. And if I go ahead and run this and we print out my grocery list again, what you'll see is that, and actually over here, what you'll see is that the extended list is including, oh, we got a little issue here where my typing's on the right spot. So if we run this again, you'll see that the extended list also has carrots and bread. This is really nice because it allows us to put more things into our grocery list. And if we need to insert an item at a particular location, we can also use the insertion function, which is connected to the list class. And so what we'll do here is I'll go ahead and insert the item of chips at the very beginning of our list. Let's go ahead and run this. And you'll see that chips is now at the beginning. You can put any index here, so I could do 1, 7, depending on what numbers are available. So if we have five items and we tried to use 7, it would be an index out of range. So the important thing is we can put it anywhere in our list based off of the index. Sometimes we want to remove an item, and so we can use the remove function. And let's say I want to remove pairs from my list. So I can use the .remove function, which will then allow me to specify what I want to remove. And because pairs are in the list, I'm going to go ahead and remove that. We'll run it, and we'll see that the removed item from pairs is no longer there. Something to be aware of is if you try to use .remove on a list and it's not there, you'll actually get an error. So if I were to try to remove pizza, is pizza in my list? Let me double check this real quick. It is not. So if I tried to remove pizza, and I would go ahead and run this code, you'll notice that I get this list error because the item is not actually in list. So we need to make sure that we are trying to remove an item that is in the list, and now it will work. So if we move on, sometimes we may want to remove an item, but we also want to keep it. So let's say that I want to remove an item, and I'm going to remove the second item in the list. And I'm going to do that. I'll just go ahead and copy and paste this in from my examples. We can remove that item by either passing an index, which in this case we want to remove the second item, which is index 1 instead of index 2, which will remove, in this case it won't be pears because I've already removed it, this would be apples. And so if I run this code, you'll see that I removed apples from the list, so you can see that it's no longer in the list itself. But you can also see that I've stored into apples the value of the item that I popped off. So again, as I've mentioned in the comments, if you don't provide an index, it pulls the very last item of the list off. So if I had not provided 1 for the pop function, it would have removed bread because it's at the very end. So if we continue, maybe we might want to see how many times something appears in a list. We can do that by using the count function. Count will allow us to see how many times a given value is inside the list. So in this particular example, I'm looking for potatoes. I want to see how many times potatoes in the list. So I'm going to go ahead and run the code. And you'll notice that potatoes appears 1 time in the list. Well, let's see if we want to have a scenario where we need to have these things alphabetically sorted. Well, there's a function to do that. Inside of lists, we can actually specify that we need the value to be sorted. So if we do that, let's go ahead and run this code. And you'll notice that a sorted list is alphabetically inserted again, and that the list will always be that way. So we have sorted the values that are currently remaining in the list, and we can go forward. There's some additional functions. We can also reverse the items in the list. And this is very helpful because sometimes we need to see it backwards. So we'll go ahead and run this one last time, and you'll notice that these items can be reversed as well. Well, hopefully this has been helpful. We'll go over dictionaries next and cover some of the benefits of using a dictionary over a list. And with this though, again, hopefully this has been helpful for understanding how we can use an individual variable to store an item. I think one last thing I might do is just show how we use the index operator and to find a particular item. So if I wanted to say cheese is my variable in my grocery list, and that's going to be at index 0, 1, 2, 3. So if I put the item 3 here, we can then say print cheese, and if I do that, you'll notice that it should print cheese, which it does. So again, hopefully this is helpful. Let me know if there's any way that I can clarify this, make it any easier. One other thing that you might find is that you can also make these a little bit easier to read if you put them on new lines. So you can do something like this, where we can make them a little bit shorter, but then move the items down. And then if you'll notice, it's somewhat indented, and then it should, oops, if I go to the right spot, it should generally look like this. And this is a way that you may see a list, and it still behaves exactly the same, but allows us to see it a little bit easier. Again, it still is dictated with these square brackets, and you can put multiple things in there. You can do strings, numbers, tuples, Boolean values, but you can store them as a list. Thanks, class.